Now the main program is going to call subprogram 1 tab 10. So we're going to go to subprogram 1, and here is tab 10. So we know this was a call to 110. There is a storage area called 110 that stores 6 register values. It stores register values for $S to %S. That's 6 registers. Here it loads those 6 registers at the load 110. Then it checks to see if the question S register is equal to 1, 2, 3, 4, 5. If it is, it goes to EN. But all load register values are set to 0 when it starts. So here's just a routine for initializing those 6 registers that are stored in load 110. First, it sets question S to 1, 2, 3, 4, 5. So now whenever it comes back here again, it's going to go to EN and not initialize a second time. We're going to set %S register to 444 and then continue on. In the future it will go to EN right away and put in the status bar the value of %S, which when initialized is 444. Then we're going to store the values for 110. Therefore, those 6 registers being stored, %S is always going to be 444 when it's loaded. So let's execute this application. Here you can see it showing that that register is always 444. Now the main program is calling tab 11 of subprogram 1. The first thing it does is sets the X position to 200. That's the distance from the left side of the screen. Then in setting Y to 200, that's the distance from the top of the screen. Then it's setting how tall it is to 100. Then it's setting C to 4. C is going to be the number of the canvas that it's going to use. And it's going to go around a loop for I, starting with 1 and going to next I, 3, 1 added each time. So it's going to go around 3 times with I of 1, 2, and 3. Next it sets the width to how tall it is, therefore it's going to be a square. Then it sets the color to the value at the random table plus 25 plus the value of I, or the random color plus 26. And that's color is going to change each time. Here's where it sets the canvas number to the value of C, which is going to be 4, then 3, then 2. Here's where it draws a rectangle and fills it in with color. This color here. Here's where it subtracts 1 from C. So as we know, the first time it was canvas 4, then the next time this will be 3, and then 2. Then each time it subtracts 50 from the X position, 50 from the Y position. That means it's going to start closer to the left and it's going to start closer to the top. Then it makes the square bigger by 100 points. Then it's going to go around this 3 times. Let's see what it's going to look like. Well, here we see it. This is the first rectangle it drew, and remember, then it made it bigger. So this is the next one, and then this is the last one. Notice each time it moved the beginning position, which was here for the first one, here for the second, and here for the third. Now you would think that since it drew the bigger one here last, that one would have covered up these two. But this one was put on canvas number 4. What is in the foreground of this one, it's on canvas number 3, which is in the foreground of this one, which is canvas number 2, which, by the way, is where things are usually put. Therefore, even though this one's bigger, it couldn't cover this one up because it's in front of it. Now the program is going to go to tab 12, subprogram 1. First, it sets the value of x to 300, value of y to 200, the rotation value to 0, and the size to 150. Now it's going to make 4 vectors. It's in a loop for I1 to next I4, advancing one at a time. First time, each time it goes around, it's going to make another vector. It's going to put the x position here, the y position here, and here is the x and y values of the center point of the vectors, or the base of the vectors is this x and y. Now the first time it goes around, the rotation value is 0, which means this vector is going to point straight up, and it's going to go this distance straight up from the base position xy, and put the resulting values in point x plus I and point y plus I. Then it's going to increase the value of the rotation by 240. A complete circle is 960. So a change of 240 means instead of being straight up, it's going to be straight to the right. So the second vector that it makes, when it goes around the second time, r is 240, it makes a vector to the right. Then it increases r by 240 again, and the next point x and point y will be straight down. Then it does it for the 4th time, it's going to be straight to the left. So you're going to have 4 points, up, right, down, left. Then this is finished, and it's going to say the number of points it has to put in the Z control register. Since it made 4 points, put a 4 in there. Then it used the instruction dot points. Here are where the x points are and the y points. That's going to make a list of xy positions for a polygon. It's going to make 4 positions for a polygon, the x and y values that were generated when the vector was made. And it's going to set the color to this, this 8-digit number. What we know for now is this first value, 1, says it's going to make the color change from left to right. It's going to start at color 900. Then this 0 means there's not going to be any transparency, and this is the second color, 500. So it's going to go between 2 colors, but you don't have to understand that now. Then it's going to draw the polygon and fill it in with that color. Now we're going to execute it, and here you see, here are the points that it made. The color starts out darker here and becomes lighter over here. So this is the polygon that it drew. While programming, get information from the glossary by clicking Info. Thank you for watching.